4.1 Polynomial Functions and Models. So this first video is just going to cover examples 1 through 3, and it really should just be a review of what you guys did last year in Math 3. So in order to do example 1, where it's asking you to identify if a function is a polynomial or not, and then state its degree, we do need to talk about what is a polynomial. So a polynomial is a function that consists of many terms that have all positive integer exponents, and their graph must be smooth and continuous. So when you guys are working through this today and doing your classwork or homework, think about what does that graph look like? Is it smooth and continuous? And then with the exponents, are they positive whole integers? So you have examples here that you guys can be looking at. Feel free to pause the video and write it down. I'm not going to stay here for much longer. And then for the degree, we need to remember the degree is the largest exponent. So it's not just the one that comes first. It might be out of order. It might not be in standard form yet. So you want to look at the largest exponent. So when I come back to this example, in A, I have whole integer exponents and they're positive. So I have a 3, and on the first term I have a 1. But notice how this is not in order. And since this is a cube, the degree is 3, I know the graph is going to be cubic in nature. So the graph is smooth and continuous, and that makes this a polynomial. For B, this is not a polynomial because I see this x in the bottom, and the only way x can be in the denominator is if it had a negative exponent. So we need to remember x to the negative 1 is 1 over x, and that exponent would not be positive, and this would end up being a rational function, which is not continuous. There are asymptotes that stop that graph from continuing on from negative infinity to infinity. So that's polynomial, non-polynomial. In the next example, you are going to have your first look this year of quartic and quintic graphs. So a quartic graph is when the degree is 4, and it is parabolic in nature. It's going to grow a lot faster than the parabola because its exponent is 4. So it's going to be multiplying more numbers, so it's going to grow a lot faster. But it is going to look similar to it. And when it's a negative, it will drop the graph down. The quintic graph has a degree of 5. And it does look like the cubic function. And the reason this happens, that the quartic looks like a quadratic and the quintic looks like a cubic, is their exponent. So when we're looking at these as we continue on through this chapter, pay attention to that exponent, and the even exponents, the 2, the 4, the 6, the even degree polynomials will be parabolic in nature. And the odd degree polynomials will be cubic in nature. So they're going to have the same styling of graph. They might have more turning points because that exponent allows for that to happen. But for today, you're just getting your first look. So we're just looking at the parent graphs, and we're going to be graphing these through transformations. So if we remember back to our Math 1, Math 2, and Math 3 days, transformations take place depending upon where values are with your equation. So just a quick reminder, if your value is with the x inside parentheses, you have to find what makes that 0. So you would take the opposite, which is going to change the sign, and if it's a positive, it moves left. If it was a negative, it will move right because of that sign change. And then if you have a negative out front, it will flip your graph upside down. It's a reflection over the x-axis. And then if you have a constant that is being added or subtracted. That is your vertical shift. And you will not change the sign because it is already y equals. There's no change that needs to take place. So you might want to write that down. And so here, let me just briefly go over where I got these graphs from. So the green graph on example A is the actual new graph. If I remember what this looks like, it's a quartic graph, so it's an x to the fourth. It will look like a parabola. Vertex is at 0, 0. When I plug in 1, I get 1. When I plug in -1, I get 1. It's going to change when you plug in 2, because you would get 2 to the fourth, which is 16, and -2 to the fourth, which is -16. So it is going to grow really fast. So there would be my original, and then since my value is with the x inside the parentheses, that's a horizontal shift of left 1. So I just took that graph and moved it to the left 1. And then on B, we have a quintic graph here with the exponent of 5, and it has 2 shifts. I have a value inside with the x, so that's a right horizontal, and the value, that's the constant, is the vertical, so up 2. So I have my original graph, which is in green, and it's starting at, I plug in 0, I get 0, I plug in 1, I get 1, I plug in -1, I get -1. So there's my original. So now I've got to take all 3 of those points, and I'm going to move each of them up 2, right 1, up 2, right 1, up 2, right 1. So then I know the nature of the graph, so I can just draw my curve going through those 3 points. And that's pretty much it for example 2. And then in example 3, you are going to have some work here in example 3, but it's really very algebra work. Very basic. You guys can multiply, you guys can add, you guys can combine like terms. So in example 3, you are having to form a polynomial function whose real zeros and degree are given. So we need to think back. If I was given a function that needed to be factored, so let's say I was given x squared plus 4x plus 3, and I needed to solve for x. I would have to factor this, so I'd have x plus 3 and x plus 1. And then I would need to set each of these factors equal to 0. And then in solving for x, I end up having to move the 3, and I move the 1, which does change the sign. So what you are being asked to do in this example is, if you're given the solutions, if you're given the zeros, those x-intercepts, you need to write the original polynomial function in standard form. So we have to know that when we're going backwards, to put them back in parentheses, we must change the signs. So that's what I'm doing here. I am taking my 3 zeros and I'm plugging them into parentheses by changing the signs. Then it's just multiplication. You're going to multiply through. You're going to distribute. Please take your time with this. This is not something I am going to go over with you guys. It's something that I do expect you to know, having gone through this for the last few years since quadratics. So take your time, be patient, make sure you do change the signs, and then multiply through carefully. The difference in B is that you do have 4 terms, 4 factors. So you're going to have 4 sets of parentheses. It does not matter the order in which you guys multiply. Pick 2, multiply them. Take the other 2, multiply them. And then take those and multiply them together. That is completely up to you. My reasoning for picking the x plus 1 and the x minus 1 was because I know that that is a difference of squares, and it will give me x squared minus 1. And then I went ahead and I multiplied the x plus 3 with the x minus 4 over here, and got my answer of x to the second minus x minus 12, and then I just multiplied it by the x squared minus 1. Again, you're going to have to take your time, be patient. It's probably not a good idea to skip work there. Okay, do the best you can, but it's one of those things that the littlest mistake, even a sign error, can mess up this problem. So attend to precision, please, and if you have questions, write them down, and be ready for your classwork tomorrow.